Hello everyone. Today's topic is friction. Now, friction is Newton's laws of motion part 2. So what is this type of force? So till now we have seen three type of forces, that is weight, normal force and tension in the string. Now let us see what type of force this friction is. So what is the definition of friction? When two bodies are kept in contact, electromagnetic forces act between the charged particles at the surface of the bodies. Thus each body exerts a contact force on each other. The magnitude of the contact force acting on the two bodies are equal, but their directions are opposite, and therefore the contact forces obeys Newton's third law of motion. Okay, so basically, what is friction? What friction is? Basically, when we try to see this thing in a magnified way, we see that the body is not the surface of the body is not perfectly smooth, and also the surface on which the body is kept, it is also not perfectly smooth. There are some bulges on the body, so because of it there is some frictional force. You can just understand it as, you see straight road, you can go fastly on a straight road, but if you see a road which has many bumpers and which has many obstacles in it, so there you will feel some resistance while traveling on it. So similarly here it is not perfectly, these surfaces are not perfectly smooth at micro level. So because of it friction is present, because of it friction is present over it. Okay. Now this was the basic definition of friction. Now let us see what is the magnitude. The direction, magnitude and direction. The direction of the contact force acting on a particular body is not necessarily perpendicular to the contact surface. We can resolve this contact force into two components, one perpendicular to the contact surface and the other parallel to it. The perpendicular component is called the normal contact force or normal force, generally written as N, and the parallel component is called friction. Therefore, if R is contact force, then R is equal to. So, in the previous part of the Newton's laws of motion, we saw that the only contact force was present as normal. But in reality, there are two contact forces present, that is normal and friction. So we write this contact force as root of friction square plus normal square. And basically this frictional force depends upon normal only. Okay. So just a reminder, while solving questions, if the question has not given coefficients of friction, or if the question is saying you can assume the surface as smooth, then you will not consider friction force. At that time, you will consider normal force as the only contact force. But if they are giving you in the question that there is a rough surface, or if they give you the coefficient of static or kinetic friction, then you will always consider friction force as the contact force, and its magnitude is given as this, the magnitude of the contact force. Now we will see the magnitude of frictional force in the next slide. Okay, reasons for friction. Interlocking of extended particles. I have already told you that at molecular level, uh, these surfaces are not basically smooth. These surfaces has bulges. The surface has small bulging outwards, and the surface is molecularly bulging outwards and inwards. Bonding between the molecules of the two surface or objects in contact. So we have read in gravitation that that any two bodies attract each other because of gravitational force of attraction. Similarly, these two surfaces has some mass. These two surfaces has some charges. So at the molecular level, the two bodies the two bodies will have some attraction due to gravitation and electromagnetic force. Okay, this was the reason for friction. Now let us see friction force, types of friction forces. So there is kinetic and static friction. Kinetic friction is the friction when the frictional force is acting when a body is in motion. And static friction is the type of friction when the body is not in motion, but it is lying still at the surface. So let us see. So you may assume what is kinetic and static friction is. Suppose there is a box kept on the ground and you start pushing the box. You see, you are pushing the box and you are applying some force. So there is some resistance while you are pushing the box. Suppose the case could be that you put the box on a skateboard and then push it. Then it becomes easier to push the box. But if it is kept on a rough ground, or it is normally kept on the horizontal rough surface, then you feel that you have to apply some more force to push the box, because there is some additional friction acting on it, and since the box is in motion, that friction is kinetic friction. Now, what is static friction? Suppose there is a very huge box kept in front of you. The box is of, let's say, 200 kgs. Now, suppose if the box was kept on a perfectly smooth surface where there is no frictional force. So at that time, if you just apply a little force, with that little force only, that 200 kg block will move. But now, since no surface is a smooth surface, now at this point, if the box is kept on a horizontal surface, and if you are applying some force, say 100 newton, so you are applying some force of 100 newton, but the box is not moving. Why? Because there is friction present in the surface of the box and the horizontal surface. So we might think that we are applying some force 100 newton, but still the box is not moving. So which force is cancelling it? So frictional force is cancelling it, and that frictional force value is equal to 100 newton. So that would be basically cancelling the cancelling our applied force. So that type of friction is static friction. We will understand it in the further examples. Okay. Direction. Let us first see kinetic friction. So I have told you kinetic friction exists between two contact surface only when there is a relative motion between the two contact surface. It stops acting when relative motion between two surfaces ceases. The direction of kinetic friction. It opposes to the relative velocity of the object with respect to the other object in contact considered. So what is the direction? It is opposed to the relative velocity of the object with respect to the other object. Note that its direction is not opposite to the force applied. It is opposite to the relative motion of the body. Now this thing is very important. You should always consider this, that the frictional force is not in the direction opposite to which any force is applied on an object or a body. Basically, the kinetic friction is opposite to the relative motion of the body. So while writing the direction of the friction, or while assuming the direction of the friction, we will always assume that the we will always check what is the relative velocity of the object with respect to another object. There is this example. Find the direction of kinetic friction. Now there is this 1 kg block, some force 1 Newton is applied here, and its velocity is here. So the direction of kinetic friction will be, so there is this ground at rest, velocity of ground is v is equal to 0, and the velocity of block is in positive x direction, v is equal to 5 meter per second. So the block's relative velocity is here in the positive x-axis direction. So friction would be acting in the negative x-axis direction. This friction would be supporting the force is equal to 1 Newton. So solution A is our answer. Let us see this example number 3. Let us see this example number 2. The correct relation between magnitude of F1 and F2 is. So basically, for here the diagram is not given. Let us see example number 3. All the surfaces as shown in the figure are rough, so we have to consider friction. Draw the frictional force on A and B. Now for A and B, we have to draw the friction forces. The velocities are given. So first of all, let us see how many friction forces would be there. There are two contact surfaces, one between A and B, and second between B and the ground. So we will be writing two frictional forces. So one frictional forces would be here. So for B, the relative velocity of B is in positive x, so friction would be acting on friction. So for B, there would be a friction in the left direction, and at this surface, the relative velocity of B is again in the positive right direction. So for this, again, the friction on B would be in the left direction. Now considering A has only one contact surface. So for A, the relative motion is in left, because for A, frictional relative velocity is 10 minus 20, that is with respect to B. So for A, the frictional would be opposite to the relative velocity, so friction would be acting in the right. Okay. Now let us see some more questions. Find out the acceleration of the block as shown in the figure. This is a block of 10 kg. This is basically 30 Newton force is being applied, and the coefficient of kinetic friction is given as zero point 0.5. So first of all, let us see the magnitude of kinetic friction. So the magnitude of kinetic friction is basically mu n. So basically, the magnitude of kinetic friction comes out to be mu n, and basically the static friction's value and the magnitude of static friction is basically from the magnitude of static friction is a range, that is, it lies between 0 to mu n. Mu n exact mu n is the kinetic friction, and the range 0 to open mu n is static friction. So for this block, 30 Newton force is applied here, and the block is 10 kg. So frictional force here would be 50. So the block would not be moving. So acceleration would be 0, because maximum friction here can be 50, but only 30 Newton force is applied. And if we talk of what frictional force is there between this block and the ground, so that would be only 30 Newton, because it is the only required frictional force. We have already seen what static friction is. Here are some notes. Direction of static friction. So follow these steps to know the direction of static friction force on an object. Draw the free body diagram. Include pseudo force. Decide the resultant force and the component parallel to the surface. The direction of static friction is opposite to the above component of the resultant force. Since no relative motion is since no relative motion comes into picture while we are talking of static friction, so we do not say that the direction of static friction is opposite to the relative motion of the body. We will say the direction of static friction is basically in the direction opposite to the net resultant force that is applied on the object. Magnitude of kinetic and static friction. Kinetic friction magnitude is mu kn, and static friction's magnitude lies between 0 to F max, and F max is basically mu n. So static friction can be anything from 0 to mu n. So here is this graph. There is some object kept here. The coefficient of static friction is mu s, and the coefficient of kinetic friction is mu k. Basically, for static friction, the maximum static friction can be mu s n, and the range is from 0 to mu Sn, and kinetic friction is mu Kn. So you should know that mu S and mu K are two different coefficient of static and kinetic friction respectively. So here some forces applied. So there is this graph. So this graph is sometimes directly asked in JEE. So you should be able to remember this graph. Here is this applied force on the x-axis and friction is on the y-axis. So how if we increase the applied force, the friction acting on the box increases. It increases rapidly and linearly with the applied force. Then at a certain point, it reaches to mu s n, and at the point where it reaches to mu s n, from that point, if the force exceeds mu s n, then from that point, kinetic friction will be applicable, and the value of kinetic friction is mu kn, no matter what force is applied now. Here is this table of coefficient of frictions, but you are not required to remember these. Okay, now we will see rolling friction.
वो का जैकेट कौन सा ये है ये तो आईआईटी कानपुर रघु कहाँ रखा है वो आके ले बेटा रघु
Okay, now let us see some questions on friction. So the most basic problems is two block problems. So what does two block problem says? Find the acceleration of the two blocks. The system is initially at rest and the friction coefficient are as shown in the figure. So there is this block A and there is this block B. The masses are given 10 and 10. This coefficient of friction between these two blocks is zero point 0.5 and a force of 50 Newton is applied on block A and this surface is smooth. So what we would the basic method to solve this question is, first of all, make force diagram, show static friction force by F because the value of friction is not known at the moment, calculate separately, then calculate acceleration. So first of all, let us assume that uh, they are they are in motion. So in this case, this will be moving since force is applied on it, and since force is applied on it, there would be some friction between these. First of all, let us assume that they move separately. Case one is they move together. Case two is they move separately. So if there would be static friction, so they would be moving together. So we take that the case one is they are moving together and there is some static friction between them that is known as F. So when they are moving together, we can take these two as a single body, and this whole mass would be 20 kg, and the acceleration would be force upon mass. So acceleration would be 50 upon 20, that is 5 by 2. So we know the acceleration now. Now we will compute the value of small f from here. So value of small f would be capital F minus small f is equal to 10 into acceleration, 10 into 5 by 2. So 10 into 5 by 2 comes out to be 25, and 50 minus small f is 25. So we get F is equal to 25 newtons. So friction's value is 25. And for this, we again take small f is equal to 25 upon mass. So we try to see that what value for this, what value of friction comes from this. And we see that the value of small f comes out to be 25 for this. Since again the value of small f comes out to be 25 here, and we see that small f can be anything between 0 to 50 because for this system mu is given as 0.5. So this maximum value of the friction acting between this contact surface can be 15 newtons because the value of maximum static friction is mu s n, and for this the normal would be 100 newtons. So zero point 0.5 into 100 newtons is 50. So since the friction's value here can be between 0 to 50, and the friction's value comes out to be, since the friction's value comes out to be 25 newton, so we say our case 1 is true. So we need not check the case 2. Okay. And there is this another question where again they are asking to find the acceleration of the two blocks. The system is initially at rest and the friction coefficient are as shown in the figure. So for this case, again, the acceleration would be 5.1 initially. Okay, so let us see what would be the case here, because in the previous question, the force here was 50 Newton, and in this question, we have the force as 101 Newton. Now, first of all, let us assume in case 1 that they are moving together. So when they are moving together, we see that force is equal to mass into acceleration, and we will assume them as a single body, and this ground is smooth. So when we are assuming them as a single body, so we get force is equal to mass into acceleration. So 101 upon 20, that would be 5.05. So if they move together, the acceleration would be 5.05. And from this, here we know the maximum friction force can be 50 newtons. But if we try to compute the friction force here, that comes out to be 50.5. 50.5 is greater than 50 newtons. So our assumption our assumption becomes false. So from here we know that they are not moving together. So we will take another case that they are moving separately. So since force is applied on this A block, so this A block would be moving forward. B will also be moving forward. But let us see how frictional force would be acting. Let us see that A would be moving forward and it will have velocity more than B because no force is acting on B and only a force is acting on A. So we can see that A will have a velocity in right, and since its velocity is greater than B will also have a velocity in right, and since the velocity of A is greater than the velocity of B, then the relative the relative velocity is also in right. So there would be a frictional force in the left that would be acting on A. Similarly, for B, there would be a frictional force acting on right because for B, velocity of B is less than velocity of A. So relative velocity of B with respect to A would be in negative x-axis direction. So friction force would be acting on kinetic friction would be acting in the right direction for B. So for here we can make the equation 101 minus F, which is we know now, which is 50 newtons upon 10 is equal to acceleration, and acceleration of B is 50 upon 10, that is 5 meter per second. So these are our two answers. Now let us see some more questions. Now, example 31. What does example 31 says? In the figure given below, force F applied horizontally on lower block is gradually increased from 0. Discuss the direction and nature of friction force and the acceleration of the block for different values of F. Now let us see. There is this smooth ground, and here mass of the block B is 20 kg and mass of block A is 10 kgs. A force of 120 Newton is applied on it, and the coefficient of friction here is 0.3. Now let us see. Gradually a force is applied on B. So let us first assume when force is 0. Now when this force is 0, this again became the case as we discussed above, that here we will make two cases. The first case when they are moving together, and second case they are moving separately. So from that point we can know the acceleration and the direction of coefficient and the direction of static friction that is being acted on A and B. Now case 2, when F is increased from 0 till the two blocks just start moving together. So suppose at which value of F will the two blocks will start moving together. Initially, initially we know that the two blocks are moving with different velocities. Block A was moving with 9 meter per second and block B was moving with 1.5 meter per second in the right side. Suppose for a value of F, these two moves start moving together. So There we can write F plus 120 upon 30 is equal to some acceleration. So acceleration of A would be 120 minus 30 upon 10, which is 9. And acceleration of B would also be the same. So F plus 30 upon 20 would be equal to 9. And we get F is equal to 150 Newton. So when F is between 0 to 150, the blocks do not move together and the friction is kinetic. As F increases, acceleration of block B increases from 1.5 meter seconds to 9 meter per second. Now let us see an example of rolling friction. So here the wheel shown is fixed at O and is in contact with a rough surface as shown. The wheel rotates with an angular velocity omega. What is the direction and nature of frictional force on the wheel and on the ground? So in these cases, the friction can act in the forward direction or the friction can act in the backward direction. Because since the wheel is in pure rolling motion, so there can be two cases. The wheel is skidding, where in which case is the wheel is in slipping motion. Another case Another case can be the wheel is in pure rolling motion. And the third case is wheel the wheel is slipping and also in rolling motion. So the first case is wheel does not rolls, it just slips. So for that case the friction would be in the backward direction. The second case is the wheel is rolling forward. So at that time the wheel has the velocity omega as in clockwise direction, and now to decrease this omega there would be a friction acting in the forward direction to decrease the value of omega. And we will see the wheel will slow down. So that is the case of pure rolling motion. In the third case, in the third case, you will observe that the wheel is doing slipping and rolling motion. So that uh, in that in that case, the friction can act in the backward direction or the friction can act in the forward direction, depending upon the forces applied and the conditions. So at that time of solving the questions, we will assume that this wheel that the friction might be acting backwards. And with this backward direction, we will solve the question. And after solving the question, if we get the value of friction as a negative value, then we will say the magnitude of the friction is the friction that we have got, but the direction of friction was in forward direction. So this was the case of rolling friction. So you just need to remember that rolling friction has three cases. One, that the body is that the body is in slipping motion, that the body does not rolls. Second, the body is doing pure rolling motion. In slipping motion, the friction acts backwards. In pure rolling motion, the friction acts in forward direction. And in slipping and rolling motion, when there is this combined motion of slipping and rolling, the friction can act in either backward direction or in forward direction. Now let us see this example number 25. Now first of all, try this example number 25. Okay. Now what does this example number 25 says is a force F is gradually increased from 0. Determine whether the block will first slide or first lift up. So this force is acting on an angle of 37 degree. So we can make this. So we can now make some components of this force. There would be a component F sine 37 degree. And this type of question was came in JEE Mains 2022. And let us see what it is trying to say. Now let us make components of this force. There is one component F sine 37 degree in the y direction, and the second component is F cos 37 degree in the x direction. So F cos 37 would be F into 4 by 5. F sine 37 degree would be F into 3 by 5. So now let us assume that frictional force here would be 0.5. Now let us first assume that the block will first lift up. Now if the block first lifts up, then at that point acceleration would be equal to 0, and F sine 37 degree would be equal to 100 kgs. Now if F sine 37 degree is equal to 100 kgs, then F would be equal to 500 by 3 newtons. Now since F is 500 by 3 newtons, so from here we will get that F cos 37 would be 400 by 3 newtons. Since F cos 37 is 400 by 9, it would be F cos 37 would be 500 by 3 into 4 by 5. 500 by 3 into 4 by 5 would be 400 by 3 newtons. And we see that the value of 400 by 3 is more than 50 newtons. That is the friction, that is the maximum friction that here, the what the maximum friction here can be. So this is not possible. So the block will first slide. So from this we say, therefore the block will begin to slide before lifting, because while taking the case that the block will first lift up, this cannot be the case, because the block will already be starting to slide, because we have got that F cos 37 is 400 by 3, which is greater than this friction. So block has already started sliding before the block has lift up. So we will say that block has begin to slide before lifting. Okay. Now let us see some objective questions. So here are some objective questions. So starting from a rest, a body slides down a 45-degree inclined plane in twice the time it takes down to slide down the same distance in the absence of friction. The coefficient of friction between the body and the inclined plane is. Now let us try to solve this question. Assume that there is a plane of 45 degree. So what it says is, starting from rest, a body slides down a 45 degree inclined plane in twice the time it takes to slide down the same distance in the absence of friction. So let us say when there is some friction, if the time it takes is 2t, and when there is no friction it takes time t. Now the coefficient of, they are asking us the coefficient of friction between the body and the inclined plane. Now let us say that this slant height is d, and this slant height is d again. Now we know the plane is of 45 degree. The plane is having an inclination of 45 degree. So we will write the equations of kinematics here. So here we will say that here mg sine theta is acting in the downward direction, mg sine 45 is acting in the downward direction. We will write that displacement is equal to half a t square. So we can write the equation as s is equal to ut square plus half a t square. So we can write that since initially the the box was at rest, so we can write as distance was half a t square. Therefore we can write it as d is equal to half a is basically mg sine 45 mg 1 by root 2, and time is t. So we write time is 2 root 2 d by mg in the case when there is no friction. Second case is when there is friction. So at that time acceleration would be g by root 2 minus f by m, where F is the frictional force. So at that time 2t becomes 2 root 2 m divided by gm minus f. So when we equate these equations, so when we put it here, we get 4 times 2 root 2 d upon g, which is equal to 2 root 2 md upon gm minus f. This value of f can be written as mu mg cos theta, and mu mg cos theta is mu mg by root 2. M cancels, we get g root 2 minus mu. G cancels from here. Here we get a root 2. D cancels. Basically, from this point, we get root 2 minus mu is equal to root 2 by 4. So mu comes out to be root 2 into 1 minus 1 by 4. Basically, mu comes out to be root 2 into 3 by 4. So 1.414 into 0.75. So that basically comes out to be approximate 0.80. So here the value of kinetic friction is 0.80. Okay, now what does this question says? If the normal force is doubled, the coefficient of friction is. So we know that the coefficient of friction depends upon the two bodies. So if in case if in case the normal force doubles, the coefficient of friction will not change. So D is the correct answer. Now here this question says a box A is lying on the horizontal floor of the compartment of a train running along the horizontal range from left to right. Okay. At time t it decelerates. Then the reaction R by the floor on the box is given this way. So we know there is this floor and this is a rough horizontal floor. So when the train is acceleration, this is a non-inertial frame of reference. So when the train is this accelerating, so it is accelerating in the backward direction. So there would be a pseudo force here that is applied, that is that will be applied on the box here, and because of it there would be a frictional force in the backward direction. So in the since on the box there is a frictional force in the backward direction and a normal force in the upward direction, we will say that there would be a net force on the box in the left as the option C suggests. So we will say that C is the correct option. Okay, now let us see this question number 19. A fixed wedge with both surfaces inclined at 45 degrees to the horizontal as shown in the figure. A particle P of mass m is held on the smooth plane by a light string which passes over a smooth pulley A and attached to a particle Q of mass 3m. It rests on the rough plane. The system is released from rest. Given that the acceleration of each particle is of magnitude g by 5 root 2, then then they are asking these three questions. So let us try let us try to answer these questions. So this side of the plane is given as rough and this side is given as smooth. There would be a friction acting here and there would be no friction acting here. So what does the question says again? The question is asking us to find the tension in the string. So here we have been given that acceleration of each particle is of the magnitude g by 5 root 2. So let us suppose since the mass of this block is more, so this particle q would be going in the downward direction, p would be going in the upward direction. So let us say there is a tension T in the string. So here the only driving force is tension and the weight. So for this an equation can be written as T minus mg sine 45 degree is equal to mass into acceleration, that is basically g by 5 root 2. So for this tension would be mg by 5 root 2 plus mg by root 2. For it, tension can be written as mg by root 2, 1 plus 1 by 5, which is equal to 6 mg by 5 root 2. So for this, our answer is this. Tension is 6 mg by 5 root 2. Now in the above question, the coefficient of friction between Q and the rough plane is. Now they ask us what is the value of mu here at the rough plane. So we can know the value of mu at the rough plane is. So now since we know the tension in the string, we can write the force we can write the Newton's second law of motion equation at the particle q. So we will write F net is equal to mass into acceleration. Since we assume that q is going in the downward direction, so there would be a frictional force acting in the direction opposite to its motion, opposite in the direction opposite to it relative motion of the block q. So we can write the equation as mg sine 45 degree minus cos 45 minus t is equal to 3m into acceleration, which is basically equal to g by 5 root on g by 5 root 2. On solving this, we'll get the value of mu. Okay, thank you.